So today I'm going to be doing the Taylor series review for the AP test. So we'll start off with this first sample FRQ question. We're given a table with a function f and its derivatives at different values of x. And so we're supposed to write the equation of the second degree Maclaurin polynomial, which, as we know, a Maclaurin polynomial is just a Taylor polynomial, but centered at x equals 0. So Maclaurin polynomial is just f of 0. Switch to a thinner one. Too thin. Let's try this. Yeah. F of 0 plus f prime of 0 times x plus f double prime 0 over 2 factorial. This is technically over 1 factorial. And this is technically over 0 factorial. X squared, so on and so forth. So basically we're just substituting in these values. So we get 3 for f of 0. Then we subtract 2x because the second derivative is, or the first derivative is -2. And then we're adding 1/2 over 2 factorial, which is just 1/2 over 2 or 1/4 x squared. So that's part A, pretty simple. Now for B, let g of x equal f of x times the sine of x. Find the third degree polynomial g of x centered at x equals 0. Okay, so sine of x, Maclaurin series is negative x, or wait, no. I believe it's positive x plus, or no, minus x cubed over 3 factorial plus x to the 5th over 5 factorial, and so on and so forth. So we're multiplying this by the terms in f of x, which we found above, and it's just the third degree Taylor polynomial. So if when we're distributing or multiplying these polynomials, if the degree of x is higher than 3, then we can just ignore it. So first off, 3 times x is 3x. And we'll do x times -2x is -2x squared plus 1/4 x cubed. Now subtracting -3 or x cubed over 3 factorial times 3 is 3x cubed over 3 factorial. And yeah, any other combinations will yield something that's higher than third degree. So this is all we have, and then simplifying this, we'll say 3 over 3 factorial is just 1 over 2 factorial, or 1 over 2, so x cubed over 2 minus, or no, plus, wait, or negative x cubed over 2. That's why I got confused. And then we're adding 1/4 x cubed to that. And then we are subtracting 2x squared and adding 3x. So we get negative 1/4 x cubed minus 2x squared plus 3x for part B. And for C, it got cut off a little bit. Let me just check. Okay, it's from 2. There. let h of x equal that. Write the second degree Taylor polynomial p2 of x for h of x centered about x equals 1. Okay, so let's just write out. This one I'm actually going to need quite a bit of space, so I'll do it off to the side. First off, we will write down that the Taylor polynomial center at x equals 1 is going to be h of 1 over 0 factorial plus h prime of 1 over 1 factorial plus h prime of 1 over 2 factorial. Oh wait, this is times x. Oh wait, times x minus 1. Of 1 over 2 factorial. There we go. And so we need to find out what h of 1 is, what h prime of 1 is, and what h double prime of 1 is. So h of 1, let's just plug in 1 equals 3 minus, well, integral from 2 to 2 times 1, which is just of f of t dt, is 0 because we're taking the, where did I put my pen? Hold on, let me find it. Okay, we're good. So any definite integral that has the same bounds, the same lower and upper bound is going to be equal to 0. So this we can say is equal to 3. And now moving on to h prime of 1. Well, we're just taking the derivative of 3x squared minus 2, or the definite integral from 2 to 2x of f of t dt. So power rule for the first one, pretty simple, 6x. And then I'll put in the 1. And then subtracting. This is a fundamental theorem of calculus, sort of a technique. And we get, we'll substitute d2x into f of x, and then times 2 dx. So it's going to equal this, 2 times f of 2x. And this equals, well, this is just 2 times f of 2 times 1, so 2 times f of 2. And if we look above, f of 2 is 2. So 6 minus 2 equals, or 6 minus 2 times 2 is 2, because 6 minus 4. And now h double prime of 1 equals, well, let's just take the derivative again. So we had 6x above, that now becomes 6. And then instead of 2f of 2x, we get 2 f prime of 2x times, we got a chain rule, so times 2. And so now this is essentially 6 minus 4 f prime of 2, which is f prime of 2 is 2, or no, f prime of 2 is negative 1 times negative 4 is positive 4, so 6 plus 4 equals 10. And so now we have these 3 values, and we can write out the answer to C, which is going to be 3 plus 2 times x minus 1 plus 10 over 2 factorial x minus 1 squared, which just simplifies to the following. we go. Oh, oops. Now moving on to part D. When x equals 1/2, the terms in the series for h of x alternate in sign and decrease in magnitude to 0. Use the polynomial from part C to approximate h of 1/2. Show that the error between h of 1/2 and the second degree Taylor polynomial is less than 1/40. So this one, it's pretty clear. They're pretty heavily hinting how they want you to do it. They terms alternate in sign and decrease to a magnitude of 0. So we know that that h of x is an alternating series. An alternating series that converges because the terms decrease in magnitude towards 0. So, and we're finding the error. So alternating series error bound is just the next term. So since this is the second degree Taylor polynomial, we'll find the third degree term in the Taylor polynomial, or the next term, not necessarily third degree, but in this case it is third degree, of the Taylor polynomial. And so we will get that the error is going to be less than, I'll just write a sub 3 of 1/2. And so the third term would be the third derivative. So third derivative, actually I'll just write the triple prime. I think that's the custom of 1/2 over 3 factorial times x minus 1 cubed. In this case, x is 1/2. So that's negative 1/2 cubed. So negative 1/8 times, or over 3 factorial. So times 3 factorial is 6. So, and then we're looking at h prime, or h triple prime of 1/2. And so h double prime we already found was 6 minus 2, or 6 minus 4 f prime of 2x. So h triple prime of x is going to equal, well, the 6 goes away, and so we get 4 f double prime of 2x times 2 again, which is 8 f double prime 2x. So now we're substituting in 1/2. Equals 8 f double prime of 2 times 1/2, or 1. So f double prime of 1 in this case is 2/3. So 2/3 times 8. Oh wait, I made a mistake. I accidentally substituted in the x here when this should be 1. This should be c. So 2 times 1. So f double prime of 2 is, wait, let me see. Yeah, f double prime of 2 is negative 1/8. And we are multiplying that by, oh wait, this is negative. There we go, by negative 8. So this equals 1. So we are left with 1 over 8 times 6 times 1, which the absolute value of this, because it's error, equals 1 over 48. And 1 over 48 is less than 1 over 40. So that is the first free response problem. Now give me a second and I will bring over the second free response problem. let a sub n equal negative 1 to the n over n times 3 to the n minus 1. So now at part A, the Taylor series for the function f centered about negative 1 is given by this. Determine the interval of convergence. So this is just going to be a ratio test to determine the interval of convergence. So let's write it out. The limit as n approaches infinity of the absolute value of. So it's going to be a sub n plus 1, which I'll just write as negative 1 to the n plus 1 over n plus 1 times 3 to the n plus 1 minus 1. And this is times x plus 1 to the n plus 1. And then we're going to multiply by the reciprocal, and this time without the n plus 1s. So it's just going to be n times 3 to the n minus 1 over negative 1 to the n x plus 1 to the n. And now simplifying this, let's see, we can cancel out this with this. We can cancel out this with this. We can cancel out this with this. And then the n's also, but that's the limit. So n over n plus 1 times x plus 1, or negative x plus 1 over 3. So now the limit as n approaches infinity of n over n plus 1, that's just going to equal 1. And then the absolute value gets rid of, we don't care about the negative because of the absolute value. So we will say that the absolute value x plus 1 for this series to converge must be less than 1. That's the ratio test. And now we'll write it like this. And now negative 3 is a less than x plus 1 is less than 3. Okay, so now we have to test the endpoints. So first let's test negative 4. And if we put in negative 4 to the original, let's just let's do it off to the side here. Here, I'll just write check negative 4. We are going to get a sub n, which is, let me check really quick. I can't scroll for some reason. Oh, there we go. Hold on. It's not letting me scroll sideways. That is really annoying. Oh, there we go. Because I was in pen mode. So negative 4, or negative 1 to the n over n 3n minus 1. And then negative 4 plus 1 to the n. Okay. So, does this series converge? Well, let's simplify this, and we get negative 1 to the n, negative 4, or negative 3 to the n, over n 3 to the n minus 1, which equals, see, let's take out the negative 1 from the negative 3. So negative 1 to the n times negative 1 to the n is negative 1 to the 2n, and 2n is always positive, which means, or 2n is always even, which means it's always going to be an even power, so that'll just be a positive 1. And then 3 to the n cancels out with 3 to the n minus 1. So there's going to be a 3 on top divided by n. And this series is just a p-series with p equals 1, so it it diverges. So 4 is not, or negative 4 is not in the interval of convergence. Now let's check 2. Just the same process here, except we're plugging in 2. 3 to the n minus 1. Okay. Which equals this. Which equals 3 over n. And this converges because it's an alternating series. It has that negative 1 to the n part. And it's an alternating series, so and each individual term, the absolute value of it is getting closer and closer to 0. And as n approaches infinity, will eventually become 0. So we can say that that converges, so it is x, is less than or equal to 2, so this is the interval. Okay, now on to part C. Wait, no, that was only part A. Okay, on to part B then. Does the function have a relative minimum, relative maximum, or neither at x equals negative 1? So let's just write out what f of x is. We will say f of x equals this series just realized that n equals 1 is the start, but it doesn't make a difference for what we were doing before. Anyways. And at x equals the negative 1, well, this is just going to equal negative 1 to the x plus 1 plus 1/6 to the x plus 1 squared, etc. And if we take the derivative of all this, because we're looking at relative minimums and maximums, we get negative 1 plus 1/3 x plus 1. And all of these subsequent terms are going to have x plus 1 to some power. And we see that since we're plugging in x equals negative 1, that's all going to become 0. So everything after the negative 1 is 0, which means that f prime of negative 1 equals negative 1. Which means there's neither a relative max nor a relative min. And now for part C, the function g can be represented by this Maclaurin series. Write the first 3 non-negative terms and general term of g prime of x and find g prime of 2. So I'm going to do this using the general term. So g of x equals, whoops, that's messy. Okay, that's better. That a sub n, which is times x to the n. And so the derivative of this, g prime of x, is going to be, well, nothing changes with the series, but the terms, this left part is just a constant. So the right part, we do the power rule. So drop the n, or move the n down, times x to the n minus 1. And so these n's cancel. And this is what we're left with. So now we'll write the first 3 non-zero terms, which is going to be at n equals 1, negative 1, then plus x over 3 minus x squared over 9. And then the general term, I guess I'll just simplify it. There. Now we're finding g prime of 2. So g prime of 2, I see what they're doing here. So now g prime of 2, let's plug in 2 to this. And we will get, here, I'll write it like this. So it's a little more clear. Oh, whoops. So this is just a geometric series, right? Because we can take out this exponent, and r equals 2/3. So we'll just solve this like a geometric series. The first term is going to be at n equals 1, so negative 1 to this, or times 2/3 to the 0 power is negative 1 over 1 minus r, which is going to be negative 2/3. And this equals 1 over 5/3, which is, or negative 1 over 5/3, which is negative 3/5, and that is part C. So now let's go to the multiple choice. So I'll quickly get the questions here. Okay, so here's 1 and 2 of the multiple choice. A portion of the graph for the function f of x is shown in the figure above. Which of the following could be the second degree Taylor polynomial for f of x by x equals 1? So x equals 1, right about here, which means when x equals 1, it looks like the graph is positive. So that immediately eliminates b, because when x equals 1, b would yield a negative 5, which is obviously not positive. And now for the rest, I'm going to look at the first and second derivative. So first off, f of x is decreasing on this interval, which means the first derivative should be negative. So this this part should be negative. Oops. So that eliminates a. And now it is concave up. So this should be positive, this sign, because that's the x squared. So C is the correct answer. Now for 2, which of the following gives the complete interval of convergence for the series? Oops. Now number 2, which of the following gives the complete interval of convergence of the series? Oh, we have to do another interval of convergence. That is quite annoying, I must say. So let's just, well, first of all, we notice that x plus 2 is in the parentheses, so the center of this is negative 2. So we can eliminate these because the center is not negative 2. Now, for this next part, I guess we just have to test if a negative 6, if the graph converges or diverges at x equals negative 6. So let's write everything out. N, which equals negative 4 to the n. And that means the negatives cancel out and the 4 minus n's cancel out, and we're left with just 4n, which obviously diverges because the terms are just going to get really, really big. So negative 6 is not in the interval of convergence, so B is wrong, or B is correct. All right, now let me get the last set of problems. Number 3. So the third degree Taylor polynomial, or Maclaurin polynomial, is this. Find the third derivative, or find the third derivative of g of 0. So let us take the third derivative. First off, since we're taking 3, or differentiating 3 times, we can get rid of these because we'll know those will eventually become 0. And now we're at negative 3/5 x cubed, and so the derivative of that equals negative 9/5 x squared, and then the derivative of that I guess I'll draw an arrow, is negative 18 over 5x, and then the derivative of that is negative 18/5. And so the subsequent terms are all going to have an x, like the term after this, whatever it is going to have, some value, but it's going to be times x. And since we're at since x equals 0, then all of these are going to cancel out, right? This will be like c over d of x cubed, or x squared, I mean. And so those are all 0, and we are left with negative 18.5, so D is the correct answer. Okay, number 4. Almost done. This power series diverges at x equals negative 1. What must be true? So the center, we can see off the bat, is 4. And it diverges at x equals negative 1. So 4, negative 1. This is 5, which means the radius of convergence is at least 5. So all of the terms from negative 1 to 9, or wait, no. We know, I misread this, because it diverges at negative 1. It doesn't converge at negative 1. So that means the terms greater than, or less than negative 1, and the terms greater than 9, I guess I didn't have to erase this all, must also diverge. 9 might converge or diverge because it could be the, the edge, the other edge of the interval of convergence. So we don't know if 9 converges or diverges. We don't know if the series converges at 3. It could, the radius of convergence could be, 2 or anything less than 5. But we are certain that the series diverges at x equals -2 because that is less than -1. So D is correct there. And last one, what is the coefficient of the x to the 4th term of the Maclaurin series? For cosine of 3x squared, the first term, okay. So cosine of x is just what, 1 minus x squared over 2 factorial plus ... But we'll notice that since this is already raised to the 2nd power and this is raised to the 2nd power, once we plug it in, this will get the 4th degree term. And we're just going to distribute or simplify 9x to the 4th over 4. Over 2. And this is negative. So 9 over 2 is the coefficient, or negative 9 over 2, I mean. So C is the correct answer there. All right, that was all of them. Hopefully this was helpful.